Today we want to take lesson 4 of our IT training, and we want to look at the history and generations of computers. For you to be able to use computers and understand them, you need to know their history. So today we want to take a tour back to the history of computers so that you get a better understanding of what computers are. Are you here? So we'll start by talking about the very first computer. About the first computer. We are talking about the first computer. Listen. Computers started in the 19th century. In 1822, so 1822 is in the 19th century. You understand?
Yes, sir.
This 1822 is in the 19th century. Yes, in the 19th century. So computers started in the 19th century. In 1822, a mathematics professor and mechanical engineer called Charles Babbage, not Cabbage, Babbage, from UK, conceived the idea for a calculation machine that will be able to compute tables of numbers. Wow. Before this time, people had only invented machines that do manual work for humans. But this man got an idea of how to make a machine that will do the thinking work for humans. This computer was called the Analytical Engine. This computer was called what? It was called what? Now when we say computer, computer in its basic sense as a noun is anything that computes or calculates. And computing didn't start as electronics. Anything that does computing is called a computer. So anything that can calculate or compute, the word calculate means compute, is a computer. Now, this computer was called the Analytical Engine. Work on the design of the Analytical Engine started in 1833, still in the 19th century. And it was this design that the basic framework of the computers of today are based on. So the design of his calculation machine is the same design or the same underlying principles or underlying procedures and methods that we still use today. The design, the structure. Now, although calculating tools like the abacus, have you seen the abacus before?
Yeah.
Good. Although calculating tools like the abacus had been in use in ancient times since 2700 BC, the Babbage Analytical Engine was the first machine that set the course for the design of modern computers. Hence, Charles Babbage is called the father of today's computer. Charles Babbage. So in my book, you see his face, right? All right. So we are talking about the first computer, and we are talking about Charles Babbage, not Cabbage. And the reason why Charles Babbage is called the father of today's computer is because his design in the 19th century, or his invention in the 19th century, is what sets the course for the design of modern computers. He got the idea to create a thinking machine. So that alone makes him a pioneer of computers. And the design of his analytical engine is what has set a course for the design of modern computers. So this is the analytical engine. This is called the analytical engine. It's also called the difference engine. This is what Charles Babbage designed. Wow. As an engineer, he took his time to design all of this. Even today, it will be hard for an engineer to create this, but he created this. He got funding and he created this. And it can do calculations. All right. So this is a very historic photo. So we just talked about the first computer. Now let's talk about the generations of computers. So we have what we call the generations of computers. Computer advancements can be classified into 5 generations. How many generations? All right, so when computers really started, we have seen 5 generations. Each generation lasted for a certain period of time. And each gave us either a new and better design or an improvement of the existing design. So there was a time computers were one way, another time computers became another way. If you remember, there was a time monitors were big. I don't know if you saw those monitors. Or TVs. TVs were big. Did you see those TVs? Good. That was one generation of television. Today, it is difficult to find those TVs because things have changed. We are in a different generation of TVs. That same way, when it comes to computers, computers have also moved through generations. So we'll be talking about the 5 generations. We started from the first generation, second, third, fourth, and today we are in the 5th generation, but we are still using the 4th generation. Let me repeat what I said. Today we are in the 5th generation, but we are still using the 4th generation. What it means is that the 4th generation has not been wiped out yet, but 5th generation has started. So modern technology is in the 5th generation. So we have witnessed the beginning of the 5th generation. A time will come, the 5th generation will take over and the 4th generation will die out. Are you with me? Let's start by looking at the first generation. We said the first generation had a technology and also had a period of time. Your job is to remember the period that the first generation existed and the technology that powered the first generation of computers. The period was in the 20th century. And it is 1940 to 1956. Which technology powered the first generation of computers? The technology is called vacuum tubes. Vacuum tubes powered the first generation of computers. We are talking about when computers really started, when the design of computers really started, and when the world started using computers well. Hello. Before this time, there had been a lot of wars in the world. And so, governments spent their monies on bombs and guns and weapons and military and training. We didn't have peace to advance the world in the area of electronics and technology. But this particular period was in the middle of the Second World War. If you remember the Second World War. This was in the time of Adolf Hitler. In the middle of the Second World War. Second World War ended 1945. So they started in the middle of the Second World War because if you had a better technology, you could win the war. So I think government started putting money into research to design computers. Because at this time also, the first atomic bombs had also been invented. And whoever had technology had power. So at this time, we started making computers. Now let's continue reading. It says that the first computers used vacuum tubes for electric circuits and magnetic drums for memory, and were often enormous, taking up entire rooms. The first computers were so large that just one computer would take an entire room because of the vacuum tubes within it. The vacuum tubes were big. Can you see them? So if you pack 1,000 of these tubes, already whatever you are building is really big. Now let's see what happened. These computers were very expensive to operate, used a great deal of electricity, and generated a lot of heat. When these machines were invented, it was only government who had access to them. This was not a time of personal computers. Not at all. Listen, it is said that this computer weighed 30 tons. If you know what that is. Now watch this. Took up 15,000 square feet of floor space. 15,000 square feet of floor space. 15,000 square. Like a football field. Had 18,000 vacuum tubes, which was used for processing, and it required at least 2 operators. The machine was too big that at least you need 2 people to be able to operate it, because one person has to be there, another person has to be there before something can be done. Listen, when this computer was turned on for the first time, lights dimmed in sections of Philadelphia, USA. So when they turned it on, in the whole area, the whole city, there was doomsday. Because of the power it consumed, there was low current. Computers of this generation could only solve one problem at a time and had no operating system. It would take operators days or even weeks to set up a new problem. Input was based on punch cards and paper tape, and output was displayed on printouts. Now let's talk about examples of the first generation computers. There was a computer created called a Univac, very popular computer, Universal Automatic Computer, and Eniac. Eniac was also very popular. Electronic Numerical Integrator and Computer. They are examples of first generation computing devices. The Univac was the first commercial computer introduced to the public in 1951. Wow. So the Univac was introduced to the public in 1951, and it was an amazing thing to look at. The Univac was so interesting to the world, and they had to use it for the next election.
The mid-20th century. At this time, the computer was a big deal. You usually needed clearance to see one, let alone use one. This made it almost impossible for any inquisitive minds to use one without time sharing. At this time, in film and television, computers were seen as large all-knowing devices, often referred to as the mechanical brain.
Try and replace us all with a mechanical brain. He's under special assignment to Azai to see if Eniac can be adapted to this department. That means the end of us all.
Peg, calm down. No machine can do our job.
That's what they said in payroll.
Think about it from a person of the 1950s and 60s point of view. All your life, you'd been using manual tools such as slide rules or charts to do calculations, and then came an automatic computer which could magically do the maths for you. But then after this, something amazing happened. Computer technology began to evolve in capabilities, and it started doing logic, and was programmed to even play chess, things that traditionally required intelligence. In 1952, a computer called Univac predicted the outcome of the US presidential election by using some clever code and inputs on the results of previous races.
Univac is going to try to predict the winner for us just as early as we can possibly get the returns in. This is not a joke or a trick. It's an experiment. We think it's going to work. We don't know. We hope it'll work.
The machine turned out this answer that they didn't believe. The polls were telling them that it was going to be about a 50-50 election, and we were telling them it's a landslide with only 5% of the vote. And they couldn't believe that you could predict the thing as accurately as we did, which was within a few percent, with only 5% of the vote. So everybody was thrown into total confusion.
The Republic. Excuse me?
People were shocked, and symbolically, from that moment, the computer had truly arrived. In the minds of the people, it could do anything. Here's a 1960s East German film depicting a future computer of 1987. Films such as this captured the imagination of anyone watching in the day. Globally, young tech minds would have been entranced by the concept of a computer growing up. One of those young minds was Bill Gates.
These are pictures of the vacuum tubes that were used to power the first generation computers. The vacuum tube is a glass tube that has its gas removed, creating a vacuum. It controls electric current between electrodes. So this is what engineers of the time used to design the very first computers. These are first generation computers. These computers were so large but could only do little as compared to today. They took up football fields. One computer could take up a football field. Now, when we are talking about first generation computers, we are not talking about supercomputers. Supercomputers are modern computers, even though they are also large. But first generation computers were so large because of the old technology they were using, and they were so heavy and they consumed too much power. All right, let me try and see if I can get, okay, this is a picture of the Univac. The Univac weighed 30 tons. Watch this, listen to this. The Univac computer weighed 30 tons, took up 15,000 square feet of floor space, and had 18,000 vacuum tubes. It occupied an entire room and required at least 2 operators. So the machine we were actually describing, the machine we were actually describing was a Univac. This is how it looked like. And it had a console like this. This is not a screen. This is just a plain metal area and these are switches. They use these switches to control it. And someone will sit in front of the console, and someone had to go around and be controlling the rest of the system. At least two people. You needed two people to control this, and it would take days or even weeks to solve one problem. This was first generation computers. This is the Univac operator's console. This console could start, interrupt, and stop the Univac. The operator used the keyboard to send instructions directly into the computer. All right. Now let's move to the second generation. At this time, something better was invented that could control the circuitry or the electrical operations or the processing. And so we had to drop the vacuum tube because it consumed too much power and it was too big and it wasn't that powerful. And so something better was invented. So technology had a different phase, changed all of a sudden. So let's talk about the second generation computers. They use a technology called the transistor. And the period was 1956 to 1963. These periods you'll be required to remember for all examinations. Anytime you are taking an IT exam, expect questions like this, and you'll also be taking a test that has questions like this as well. So remember the periods when the second generation lasted. It started 1956, 1963. Now, in these periods, because the Second World War ended, we have had peace in the world to use our money to design computers. So technology has advanced so rapidly in this time because the wars have ended. If the wars had continued, we would still not have the technologies we have today. Maybe I'm wrong, but that's what I think. The transistor was far superior to the vacuum tube, far superior, allowing computers to become smaller, faster, cheaper, more energy efficient, and more reliable than their first generation predecessors. Although the transistor still generated a great deal of heat that subjected the computer to damage, it was a vast improvement over the vacuum tube. Second generation computers still relied on punch cards for input and printouts for output. So this is how a transistor looks like. Today we still make use of transistors, but in a different way altogether. When this transistor was invented, everything changed in the world. When this transistor was invented, technology changed up to today. These are pictures of transistors. A transistor is a device that regulates current or voltage flow and acts as a switch or gate for electronic signals. December 23, 1947 was the day the transistor was first successfully tested, but did not see widespread use in computers until the late 1950s. This technology changed the world when this was invented. Let's continue. The second generation computers, or the second generations, were the first computers that stored their instructions in their memory, which moved from a magnetic drum to magnetic core technology. In the early 1960s, the IBM 1401 and the Honeywell H800 were examples of second generation computers. You'll be required to give examples of second generation, first generation, third generation, and fourth generation, as well as fifth generation computers. During this generation of computers, over 100 computer programming languages were developed. And computers had memory and operating systems. Storage media such as tape and disk were in use. I love people who lived around this time. I love engineers who lived around this time because I think these people were more intelligent than us. That's what I think. Because the way they were able to think so deep and invent these machines and all these things, they are so unimaginable. Today we still talk about Albert Einstein, Michael Faraday, Tesla. We still talk about all these great people who lived so many years before us. Isaac Newton and all these people. Because the way they were able to invent things, they really changed our world, and their work was more difficult than it is today. So I really respect people who lived around this time. One man invented the electricity we use in our homes. Nikola Tesla. Nikola Tesla was working for Thomas Edison, the man who invented the light bulb. And he took electricity to a whole new level that it is Nikola Tesla's invention that we use. Thomas Edison invented the DC electricity, and Nikola Tesla invented the AC, alternating current. These people have done a whole lot in the world. And this was not too far long ago. Nikola Tesla, okay, he died in 1943. You see? So, people were very intelligent, and I know we are still intelligent, but when you think about what they created, you may think they are so outmoded and they are nothing, but when you go into how they invented these things, you realize that these people were so intelligent. So this is the IBM 1401, announced on October 5th, 1959, and is among the highly successful IBM 1400 series. So this is a 1401, and this is a Honeywell H800. These are second generation of computers. They were much smaller and faster than the first generation, vacuum tube design, and fit into smaller rooms. So even though they will take up entire rooms, they will fit in smaller rooms. Let's move on to the third generation. And the third generation used a technology we call integrated circuits, ICs. And the period is 1964 to 1971. The development of the integrated circuit, IC, was a hallmark of the third generation of computers. Transistors were miniaturized and placed on silicon chips called semiconductors. which drastically increased the speed and efficiency of computers. Computers became smaller, more powerful, and more reliable. So, several transistors were put or were made smaller. There were miniature versions were created, or smaller versions, or tiny versions were created, and they were put on silicon chips. And you will see that this is what also led to the development of the CPU. But this is a third generation, and it is still the transistor that has moved us into this era. And so we created what we call integrated circuits, IC. So the technology that powered the third generation is integrated circuit. As a student, when we are talking about generations of computers, you need to remember the name of the generation, the technology that powered that generation, and the period the technology lasted, as well as examples of computers of that generation. 4 things. So this is how an IC looks like. So we're getting closer and closer to modern technology. This was the integrated circuit. An integrated circuit is a set of electronic circuits on one small flat silicon chip. Many transistors made smaller in size were combined to make the IC. So when you hear something has been miniaturized or a miniature version has been created, it means a smaller version has been created or it has been made small. Something that used to be big, a miniature version is a smaller version of the same thing. These were smaller, cheaper, better, faster. Now, instead of punch cards and printouts, users interacted with third generation computers through keyboards and monitors. Wow. So this time we have real monitors. An interface with an operating system which allowed the device to run many different applications at the same time with a central program that monitored the memory. Computers for the first time became accessible to a mass market because they were smaller and cheaper than their predecessors. The floppy drive, the 8-inch disk 80 KB, came into the picture for the first time, invented by IBM in 1967. Have you heard IBM? This time IBM was really making an impact in technology. So most of the time you hear IBM computers. Last time I asked you a question about IBM. I asked you when we were talking about mainframes that who knows IBM. So IBM was a company, and this company invested a lot in developing computers and modern technology or modern IT technology. Later called the diskettes as it got smaller. CDC 6600, IBM 360, IBM 370 are good examples of third generation computers. So this time we started having monitors. Have you seen the monitors? But they were black monitors with only text and symbols. Third generation. So this is the CDC 6600 computer system manufactured by the Control Data Corporation in 1964. It became the world's fastest computer until 1969. This was the IBM system 370. Was a module range of IBM machine. IBM mainframe computers announced on June 30th, 1970 as the successors to the IBM system 360 family. Also announced by IBM on April 7, 1964. Wow. Now, at this time, or in this period, to operate a computer, you need at least a master's degree before you be allowed to touch a computer. People who use computers were people trained and employed. And computers were not that common. Only companies could buy computers at this time. And government agencies. At this time, people like Bill Gates, Steve Jobs, Paul Allen, Steve Wozniak, Linus Torvalds, they were all children. And they saw how big companies were using these machines. And they got introduced to computer education at that time. And they decided to go deeper. Someone like Bill Gates, he made a promise that he will make sure that every home gets a computer. Around this time, he was just a small boy. He said he will make sure that every home gets a computer. Someone like Linus Torvalds, he looked at the big operating system at the time called Unix and said he wants to make his own version so that he will use it himself. And he created Linux. So in the time of the fourth generation, it became possible for people to own computers. The machines we are using today are fourth generation computers. Are you with me? The machine we are using today are what? And the technology that powers the fourth generation is called the microprocessor. The microprocessor is the same as the central processing unit. Have you seen one before? This is a CPU, the central processing unit. This was a chip that changed the world forever. And if you go deep within this, there are transistors within it. It is millions of transistors that have been miniaturized and put on this chip to make this. This microprocessor is what has given birth to the technology we have come to know. And what I'm holding in my hand, so small like this, is 1,000,000 times more powerful than the first generation processing system that occupied an entire football field. This one in my palm is more powerful than what filled an entire football field. The microprocessor brought the fourth generation of computers, as thousands of integrated circuits were built onto a silicon chip. So you remember that the integrated circuits were made from transistors as well, right? Now listen, what in the first generation, listen to this, what in the first generation filled an entire room could now fit in the palm of what? Of the hand. One of the very first chips or CPUs or microprocessors that were invented was the Intel 4004 chip, developed in 1971. Located all the components of the computer from the central processing unit and memory to input-output controls on a single chip. Wow. So the Intel 4004 looked like a transistor. This is how it looks like, but it's a microprocessor. And microprocessors have also evolved. CPUs have also evolved. They were looking like this, they started looking like this, and today they look like this. This is a Core i7 CPU. If you have Core i7, you have a powerful machine. Then we have Core i9, the latest Intel CPU release. So a computer today is known by its CPU. When you have a computer today, what makes your computer what it is, how strong it is, how powerful it is the kind of CPU you have. And so today someone will say that I want to buy Dell i3. The i3 is a CPU in it. Around the year 2000, the best computers that came into the system were called Pentium 4. This Pentium 4 is not the system unit, it is a CPU in the machine. The CPU is what is called Pentium 4. When you hear Core i3 or i5 or i7 or i9, it is a CPU we are talking about. Today, almost every computer you buy has a sticker on it. It's a sticker you use to buy the computer. That sticker tells you the CPU in it. The sticker is a sticker of the CPU. Okay, so this is a Toshiba machine, right? When you want to buy a computer, we don't use Toshiba to buy a computer. Toshiba is just a brand or the company that made it. There's supposed to be a sticker. So this is your sticker, and the sticker here is what we use to buy the computer. This sticker tells me that there's an AMD CPU in this machine. Knowing this or seeing this alone will give me all the information I need to know whether the machine is okay for me or not. Today, there are two large companies that make CPUs. We have AMD and Intel. So knowing where the CPU is coming from alone gives you a lot of idea about the computer. And also checking the specifications of the CPU will tell you how fast the computer is. Almost every system unit you will find has a sticker in front. Please check your system unit and look for a sticker. You see Intel something. Read what is on it for me. I didn't say monitor. I said system unit. Check it and tell me now. Yes. Intel Core. Is it Core 2 or Core? Intel Core 2. Okay. Intel Core 2 is in front. Check in front of your system unit. You find a sticker and there's Intel something. Intel Pentium. Okay. Now, the sticker is what tells you how much the computer should cost. And what the sticker is telling you, all that the sticker is trying to tell you, is the CPU inside. The CPU in the machine is what is the Intel Core 2, or the Intel Pentium, or Pentium, or i5, or i3, or i9. It is the or i9 or i7. It is the CPU. The CPU is what determines the strength of the computer. Every other component is just there to assist the CPU. If the CPU is not strong, it doesn't matter what you have, the computer is still not strong. All right. Now, in 1980, Microsoft Disk Operating System, MS-DOS, was born. This is what Bill Gates and his friend brought. The Microsoft Disk Operating System, MS-DOS. Have you heard of MS-DOS? MS-DOS. Microsoft Disk Operating System. So, At that time, MS-DOS was the most popular operating system in the world. And it was released by Microsoft, the company of Bill Gates. And this MS-DOS is what made Microsoft rich. This is what made them billionaires. This is what made Bill Gates a billionaire. The whole world used this operating system, MS-DOS. And MS-DOS looks like this. Do you see this? Do you see this? This is an operating system. I can use this to control my computer. I can use this to get every information I want. I can use this to do whatever I want on my computer because this is an operating system. Now, this is called command prompt, and it is included in every modern Windows or every Windows. It is included in Windows, every version of Windows, but it gives you a command line interface to operate the operating system you are having. So this is an interface where whatever you want to do, you needed to write a command. MS-DOS look like this. And even if you say this is MS-DOS, you are not far from the truth. So Microsoft has made this available to us even today. And even today, we still use this interface to operate our computer. As you advance in IT, you are going to be learning this. There are certain things that if you don't know how to operate a computer from this interface, you cannot do. There are certain advanced things that it is only through this interface that you can really operate the computer to get results. So as you advance in IT, you are going to learn the command line interface. This is called a CLI operating system, command line interface operating system. And we also have the GUI operating system, graphical user interface operating system. So today we have the graphical user interface where we see pictures, we see our icons, we have a mouse pointer, we can click on what we want, we can drag and drop. Those days they didn't have the graphical interface operating system. They had a command line interface. So whatever you want to do, you need to know the command to type. You type the command, you hit enter, and the operation will be done. All right. In 1981, IBM introduced its first personal computer for the home user. Have you heard of IBM again? In 1981, they introduced the first PC for the home user. And in 84, a lot of things started from 84. Apple introduced their first Macintosh with their Mac OS operating system. 1984. 1985, Excel was introduced. Windows was introduced. 1985, Windows started. So the graphical version of Windows started. And everything started from there till today. So this was a time of Bill Gates and Steve Jobs and those who have made an impact in our time.
Hi, welcome to another Cold Fusion video. It goes without saying that the personal computer revolutionized businesses and homes around the globe. But what was the very first one? Where did it come from? And what's the story behind it? Interestingly enough, as you'll find out in this video, the PC was the impetus for both Microsoft and Apple. Let's begin. We have to travel back in time here to where this story has its prelude, the mid-20th century. At this time, the computer was a big deal. You usually needed clearance to see one, let alone use one. This made it almost impossible for any inquisitive minds to use one without time sharing. At this time, in film and television, computers were seen as large all-knowing devices, often referred to as the mechanical brain.
Try and replace us all with a mechanical brain. He's under special assignment to his eye to see if Eniac can be adapted to this department. That means the end of us all.
Peg, calm down. No machine can do our job.
That's what they said in payroll.
Think about it from a person of the 1950s and 60s point of view. All your life, you'd been using manual tools such as slide rules or charts to do calculations, and then came an automatic computer which could magically do the maths for you. But then after this, something amazing happened. Computer technology began to evolve in capabilities, and it started doing logic and was programmed to even play chess, things that traditionally required intelligence. In 1952, a computer called Univac predicted the outcome of the US presidential election by using some clever code and inputs on the results of previous races.
Univac is going to try to predict the winner for us just as early as we can possibly get the returns in. This is not a joke or a trick. It's an experiment. We think it's going to work. We don't know. We hope it'll work.
The machine turned out this answer that they didn't believe. The polls were telling them that it was going to be about a 50-50 election, and we were telling them it's a landslide with only 5% of the vote. And they couldn't believe that you could predict the thing as accurately as we did, which was within a few percent, with only 5% of the vote. So everybody was thrown into total confusion.
The Republic. Excuse me?
People were shocked, and symbolically, from that moment, the computer had truly arrived. In the minds of the people, it could do anything. Here's a 1960s East German film depicting a future computer of 1987. Films such as this captured the imagination of anyone watching in the day. Globally, young tech minds would have been entranced by the concept of a computer growing up. One of those young minds was Bill Gates, and in January of 1975, he saw a magazine cover that would change his life and the course of history. That magazine was Popular Electronics, and on the cover of that magazine was a personal computer. In an instant, all the possibilities were now within reach. There'll be more on Bill Gates later, but first, where did this computer come from? Well, 1 year earlier, in 1974, Ed Roberts, an engineer, was trying to prevent his calculator business from going under. At a meeting with his bank lenders, in a last-ditch attempt to save the company, he said that he could do something that hadn't been done before: create a personal computer kit for hobbyists. A task thought to be impossible at the time, and only made possible by the microprocessor invented by Intel just 3 years earlier in 1971. For a bit of context, the microprocessor for the first time allowed an entire computer to be put onto one chip, a truly huge feat. Roberts named the microprocessor-driven computer the Altair 8800 and sold it in the pages of the Popular Electronics magazine for $400 in January of 1975. Ed Roberts told the bank that they expected a few hundred orders at the most, but ended up being swamped with a couple of thousand orders within the first few months.
At that time, all the computers in the world tended to be in big centers, and you had to get permission to get close to them, and it was nobody had access to computers then. And the idea that you could have your own computer and do whatever you wanted to with it whenever you wanted to was fantastic.
The demand for the computer was so high that enthusiastic hobbyists parked outside of the front of his warehouse to get their hands on the computers. The enthusiasm was driven by the fact that now everything that these guys had dreamed of and seen in movies was now within reach of everyone, and moreover, it could fit on your desk. Well, almost. You see, the Altair 8800 was very primitive. There was no place to connect a keyboard or monitor, it was just a bunch of switches and lights. Although very simple, the Altair 8800 started a revolution. In mid-1975, a club was started in California in which enthusiasts gathered to discuss everything about the Altair 8800. The club's name was the Homebrew Computer Club, and one of the enthusiasts was a guy named Steve Wozniak. Wozniak later stated that it would be the very first meeting at the Homebrew Computer Club that inspired him to build his own computer, which he would bring to each weekly meeting. This computer eventually became the Apple I, the computer that started Apple. In addition to being primitive, the Altair 8800 was very difficult to use. To load an instruction, you had to flip switches. For example, let's look at how you'd load 2 + 2. Each 2 took 8 different switches and a 9th switch to load them all. The plus instruction took 8 more switches, and you would know that the answer was 4 when the 3rd light from the left turned on. A 100-byte program would take 100 switches. It kind of makes me thankful for the ease of use of computers today. Despite the hurdles though, the guys at the computer club were smart enough to come up with uses for it.
Steve Dompier set up an Altair, laboriously keyed a program into it. Somebody knocked the plug out of the wall, and he had to do that all over again, but nobody knew what this was about. After all, was it just going to sit and flash its lights? No.
You put a little transistor radio next to the Altair, and he would, by manipulating the length of loops in the software, could play tunes.
The radio began playing The Fool on the Hill, and the tinny little tunes that you could tell were coming from the noise that the computer was generated, being picked up by the radio. Everybody rose and applauded.
It was a very exciting thing. It was probably the first thing the Altair actually did.
Although this demonstration blew minds at the time, in order to be a useful tool, the machine needed a programming language. As it turns out, Paul Allen, a high school friend of Bill Gates, saw the magazine cover with the 8800 proudly sitting on it. He snatched it off the shelf and ran into Bill's college dorm room. When Bill saw it, he knew that this was it. The personal computer had arrived. But instead of getting excited, Bill saw a business opportunity and called up Ed Roberts' company, MITS, and told them that he'd written some software for the 8800 and it was almost completed. The thing was, they hadn't even started writing it yet.
And saw this popular electronics magazine. And it was kind of, in a way, good news, bad news. Here was someone making a computer around this chip in exactly the way that Paul had talked to me, and we thought about what kind of software could be done for it. And it was happening without us. And for all we knew, maybe they had some software people, they were just going to go charge off and do this thing. Because we'd never had the chip, just the book from Intel, if we'd made any mistake in terms of how the instructions worked, the thing never would have run. And so Paul was scheduled to fly out to Albuquerque. He decided to go get some sleep. I stayed up all night reading the book to see if we'd miscoded some of the instructions, and finally decided it was all okay, punch out the paper tape, and made sure Paul got that before he went off on his plane. He wrote the bootstrap loader, that is the thing you have to key in to make this computer smart enough to know to go get data off the teletype to read it into memory. He wrote that on the plane on the way out, loaded it up in the paper tape. The first time, for some reason, it didn't work. The second time they loaded in, and it worked. So it came up, said ready, and he typed in a program. Print 2 plus 2, it worked. He had it print out squares and sums and things like that. And he and Ed Roberts, the head of this company, sat there, and they were amazed by, that this thing worked. I mean, Paul was amazed that our part had worked, and Ed was amazed that his hardware worked.
And this was the first piece of Microsoft software. After this moment, the 19-year-old Bill Gates saw that he could get an early foothold on the new PC industry and immediately quit university and went to live in New Mexico out of a hotel directly across the road from the MITS factory, the company that made the Altair machine. From this hotel, Bill and Paul got to work writing more software for the 8800. Their software allowed the 8800 to now do much more. By the end of the year, people had attached terminals to the Altair and wrote games, accounting software, and word processors on top of Bill and Alan's software code, now called Microsoft. A true revolution had begun. The simple computer with switches and lights had now become a functioning machine closer to what we call a PC today, just in the span of 1 year. And this was all thanks to the software that these two kids wrote. And as we know, the rest went pretty well for Microsoft. So there you have it, the Altair 8800, the little known first personal computer. If it didn't exist, there would be no Microsoft or Apple as we know them today, or perhaps even at all. And as a side point, I think it's really cool that we can now just click a mouse and tap on a screen to load some software instead of flipping hundreds of switches. We should be grateful for that. Anyway, thanks for watching. If you think more people should learn about this golden piece of history, feel free to share this video. Also, give it a thumbs up if you liked it, or thumbs down if you didn't. If you want to see some more cool stuff from this channel, hang around for the next 10 seconds and follow the prompts on your screen. This has been Dagogo. You've been watching Cold Fusion. Cheers guys, and I'll catch you again soon for the next video. Have a good one.
Cold Fusion.
Microprocessors also moved out of the realm of computers into many areas of life as more and more everyday products began to use a microprocessor. So washing machines had microprocessors in them, microwaves had microprocessors, and a whole lot. As these computers became more powerful, they could be linked together to form networks. Networking also began, which eventually led to the development of the internet. Fourth generation computers also saw the development of GUI operating system, graphical user interface operating systems, the mouse, and handheld devices. The original Mac OS GUI was released in 1984, and Microsoft Windows, the operating system, was first released in 1985. So examples of fourth generation computers are examples of computers we are using today. All the machines we are using are fourth generation computers. So this was the IBM 5150 computer, released August 12, 1981. So IBM 5150, released August 12, 1981, was among the first fourth generation computers. So this was the first, is it a PC? First PC released by IBM. Then let's see what Apple did. Apple also brought their famous Macintosh computer. So this was the first Apple. The first Apple computer, 1984. Wow. This is Apple. Now today, look at MacBook. Today, look at Apple computer. Look at how they have become. This is how they started. Today, when we say MacBook Pro, wow. Then today, look at how iMac it looks like. 2019. Sleek. If you have this machine, you'll be happy. Look at this one. Wow. If you're a video editor, this should be your machine. Graphic designer too. So, Caesar, you and Bright, you have to buy this machine. You have to buy this machine. Wow, this machine is so nice to use. If you're a graphic designer with this machine, you love it. So all these machines are fourth generation computers, and the fifth generation of computers have also started in our time. What powered the first generation of computers? Pardon? Vacuum tubes. What powered the second generation? Transistors. What powered the third generation? Integrated circuits. What powered the fourth generation? The microprocessor or the CPU. And now we have entered into the fifth generation of computers. And the fifth generation, if you have not heard before and you are told, you will simply not believe it. I'm saying that the fifth generation of computers, if you are not acquainted with them already and you are told, you are going to be shocked. Because in the fifth generation, computers are given intelligence to do things on their own. And not what we control the computer to do, but allow the computer to do things on their own, make decisions on their own. In the fifth generation, computers are not put in the cases that we have in the fourth generation. In the fifth generation, computers are put in any case at all. Example, robots, cars. And so in the fifth generation, cars drive themselves. The car can drive on the street, see other cars, swerve other cars, speed when it has to, stop when it has to, can take you where you want to go without you driving. If your car is in the house, your car can come and pick you from here. No one is inside. You can call your car and your car will respond and talk to you like a human being. And your car can come to where you are and come and pick you. And the car will drive you. Computers have now been given intelligence to make decisions and to act like they are humans. And so the fifth generation is what we call the AI generation. The fifth generation is powered by what? Artificial intelligence. AI.
Every day, a large portion of the population is at the mercy of a rising technology. Yet few actually understand what it is. Artificial intelligence. You know, HAL 9000 and Marvin the Paranoid Android. Thanks to books and movies, each generation has formed its own fantasy of a world ruled, or at least served, by robots. We've been conditioned to expect flying cars that steer clear of traffic and robotic maids whipping up our weekday dinner. But if the age of AI is here, why don't our lives look more like the Jetsons? Well, for starters, that's a cartoon. And really, if you've ever browsed Netflix movie suggestions or told Alexa to order a pizza, you're probably interacting with artificial intelligence more than you realize. And that's kind of the point. AI is designed so you don't realize there's a computer calling the shots. But that also makes understanding what AI is and what it's not a little complicated. In basic terms, AI is a broad area of computer science that makes machines seem like they have human intelligence. So it's not only programming a computer to drive a car by obeying traffic signals, but it's when that program also learns to exhibit signs of human-like road rage. As intimidating as it may seem, this technology isn't new. Actually, for the past half a century, it's been an idea ahead of its time. The term artificial intelligence was first coined back in 1956 by Dartmouth professor John McCarthy. He called together a group of computer scientists and mathematicians to see if machines could learn like a young child does, using trial and error to develop formal reasoning. The project proposal says they'll figure out how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. That was more than 60 years ago. Since then, AI has remained for the most part in university classrooms and super-secret labs, but that's changing. Like all exponential curves, it's hard to tell when a line that's slowly ticking upwards is going to skyrocket. But during the past few years, a couple of factors have led to AI becoming the next big thing. First, huge amounts of data are being created every minute. In fact, 90% of the world's data has been generated in the past 2 years. And now, thanks to advances in processing speeds, computers can actually make sense of all this information more quickly. Because of this, tech giants and venture capitalists have bought into AI and are infusing the market with cash and new applications. Very soon, AI will become a little less artificial and a lot more intelligent. Now the question is, should you brace yourself for yet another Terminator movie live on your city streets? Not exactly. In fact, stop thinking of robots. When it comes to AI, a robot is nothing more than the shell concealing what's actually used to power the technology. That means AI can manifest itself in many different ways. Let's break down the options. First, you have your bots. They're text-based and incredibly powerful, but they have limitations. Ask a weather bot for the forecast, and it will tell you it's partly cloudy with a high of 57. But ask that same bot what time it is in Tokyo, and it'll get a little confused. That's because the bot's creator only programmed it to give you the weather by pulling from a specific data source. Natural language processing makes these bots a bit more sophisticated. When you ask Siri or Cortana where the closest gas station is, it's really just translating your voice into text, feeding it to a search engine, and reading the answer back in human syntax. So in other words, you don't have to speak in code. At the far end of the spectrum is machine learning, and honestly, it's one of the most exciting areas of AI. Like a human, a machine retains information and becomes smarter over time. But unlike a human, it's not susceptible to things like short-term memory loss, information overload, sleep deprivation, and distractions. But how do these machines actually learn? Well, while it may be easy for a human to know the difference between a cat and a dog, for a computer, not so much. You see, when you're only considering physical appearance, the difference between cats and dogs can be a little gray. You can say cats have pointed ears and dogs have floppy ears, but those rules aren't universal. Between tail length, fur texture, and color, there are a lot of options, and that means a lot of tedious rules someone would have to program manually to help a computer spot the difference. But remember, machine learning is about making machines learn like humans, and like any toddler, that means they have to learn by experience. With machine learning, programs analyze thousands of examples to build an algorithm. It then tweaks the algorithm based on if it achieves its goal. Over time, the program actually gets smarter. That's how machines like IBM's Watson can diagnose cancer, compose classical symphonies, or crush Ken Jennings at Jeopardy! Some programs even mimic the way the human brain is structured, complete with neural networks that help humans, and now machines, solve problems. Generations have long imagined the ramifications of AI, visualizing a society where machines seek revenge and wreak havoc on human society. However, the more logical and pressing question is, how will AI affect your job? Will it make your work obsolete? Just like the Industrial Revolution, it's not human versus machine, it's human and machine versus problem. The point is that artificial intelligence helps you accomplish more in less time, taking on the repetitive tasks of your job while you master the strategy and relationships. That way, humans can do what they do best: be human.
And the period is when? Present and what? Beyond. This is the future of computing, artificial intelligence. Listen, artificial intelligence is an area of computer science that makes machines seem like they have human intelligence. The goal of AI is to create systems that can function intelligently and independently, to make computers think like humans. So in the fifth generation, computers are put in robots like this. This robot can make decisions on its own, by itself. The robot can talk like a human. The robot can learn a language and speak in that language without you controlling it. The robot can do things by itself without someone controlling it. And this is real. Listen. AI is accomplished by studying how the human brain thinks, how humans learn, decide and work while trying to solve problems, and then using the outcomes of this study as a basis of developing intelligent software and robotic systems. AI machines are designed to learn on their own without being taught by humans. They learn by experience. They analyze thousands of examples and build an algorithm. Then perfect the algorithm over time until they can respond just like humans to solve problems. They retain information and become smarter over time. They are intended to function even better than humans. Because they do not have the problems that humans have, like memory loss, information overload, or distractions. They don't get tired and they don't complain like humans. These are AI machines. Who has watched the Terminator movie before? Terminator, have you heard of Terminator? Okay, Commando, right? Who acted Terminator? Schwarzenegger. So that Schwarzenegger was a machine. That is an AI machine. So that AI machine can function on its own. Can do things by itself. And today, we have some in real life like that. We have some today in real life like that. Who has watched The Matrix? People are afraid that these machines will become more intelligent than humans and they will take over the world and they will fight humans. They will control humans.
Do you remember the first time that you saw R2-D2 or C-3PO from Star Wars? These two robots exhibited human-like behavior as they interacted with people and the world around them. How about when the world was subject to machine control in the Matrix? This is a pretty frightening concept. Or even in the critically acclaimed Hollywood hit Ex Machina, when a machine was built to look, talk, feel and act like a human being. These movies, like many others, have their own depictions of what artificial intelligence looks like and means to us as a society. The term artificial intelligence has been popularized in books and movies to depict futuristic settings where machines take over the world or live with us side by side as if they were humans. Did you know that artificial intelligence is actually here with us today? That we as a society and a culture are already embracing artificial intelligence in our daily lives every day. We no longer live in a world where artificial intelligence is just a story in our books or on the big screen when we go to the movies. But if artificial intelligence is already here, what does it really look like? How does it work? And how does artificial intelligence actually compare to the fictional representations of AI in our culture? I'm Ronald van Loon. I'm a consultant, blogger, vlogger, webinar host and a keynote speaker. And I'm helping businesses achieve digital transformation and helping you to understand some of the most innovative and exciting new technologies out there today. And I'm here to tell you that it's true. Artificial intelligence is already here among us. And you're already using it. And it's very helpful to all of us. Let me tell you more about it. Did you notice that when you start listening to music on Spotify, that Spotify actually starts to recommend you new music based upon your favorite songs? How about when you're on your way to work and Google Maps recommends that you take a faster alternative route to save you time in heavy traffic conditions? What about when you're at home and you ask Amazon's Alexa to set your alarm so that you can get up early and be at your appointment on time the next day? Artificial intelligence is the backbone for these innovative technologies that we are using every single day. Artificial intelligence creates a higher degree of efficiency and productivity by automating repetitive tasks, creating immersive and responsive experiences, and understanding human sentiment and even emotions. Did you know that we are already seeing the first self-driving cars on our roadways? And you guessed it, artificial intelligence is helping self-driving cars react and know when it's safe to drive, when to brake, or respond to objects within its environment. Essentially, artificial intelligence trains and learns similarly to the way humans do, and that's pretty impressive. Humans don't need to continuously input information into computers in order to make them function the way we want. Artificial intelligence was created in order to learn just like us. So that we don't have to tell Spotify what songs we like. So that we don't have to constantly input traffic conditions and manually search for routes to work. So that we don't have to teach Alexa how to understand our speech patterns. So that we don't have to personally map every single roadway and driving scenario for self-driving cars to know how to drive. Artificial intelligence is designed to automatically learn these type of functions on its own. But how does artificial intelligence actually do this? From a technical standpoint, we teach it a mathematical algorithm, a code that helps a computer to recognize patterns in data. What do I mean by data? Well, we as a society are now in an era of data because of the technology that we are using, like our computer, our tablets and our smartphones. All of these devices, cars and machines are equipped with sensors that produce information that companies can use in their artificial intelligence technologies. It helps artificial intelligence to learn and to make decisions like we do. These type of devices are generating massive amounts of data every second. And artificial intelligence helps us to better read, understand and utilize this data for specific purposes. Let's look back at our Spotify example. When you're using a program like Spotify to listen to music on your computer, on an app, on your smartphone, data is being collected and stored by Spotify. When I say data is being collected and stored, I mean all of the songs that you listen to. What time you listen to those songs, how often you listen, and what artists and bands that you prefer to listen to. But the people working at Spotify simply can't read and sort through all of these songs you like. Because there are just too many customers and too much data for people to be able to understand it. And that's where artificial intelligence comes into play. Spotify uses artificial intelligence to look through all of this data. But artificial intelligence is special because it does not just look through all of your song choices. It starts to recognize the songs you like on its own, and the bands you play, and the times of the day that you are listening to them. Artificial intelligence even goes one step further and also starts to notice when other Spotify customers are listening to the same bands as you. It can tell that you will like a new band based upon the experience and preferences of other Spotify customers. People just simply don't have the time or the mental capacity to search through millions of songs. So we create artificial intelligence to do tasks like this for us. As a result, you have a great time enjoying your favorite songs because Spotify and artificial intelligence personalize your music experience. You know, it's exciting to think that we not only have artificial intelligence technology, but we are already using it, and many of us might not even have realized it. These really are fascinating times for us and for our technology. The next time that you make it to work on schedule by taking a faster route recommended by your GPS on Google Maps, you can thank artificial intelligence. Or when you ask Alexa what the weather looks like outside, you will start to appreciate artificial intelligence. What about the future of artificial intelligence? Well, when you get into your first self-driving car in the near future and you're reading a book or playing on the phone instead of driving, you will start to feel the full impact of artificial intelligence. Did you know that Spotify created a new creator research lab in Paris, where they will be teaching computers musical composition techniques? And this is going to help real musicians in their musically creative process and give them a more expansive range of musical tools. In the coming years, artificial intelligence is going to continue to augment many human tasks. giving people the freedom to work and to live more efficiently and capably in our everyday lives. Thank you for joining me today for our discussion of artificial intelligence. Come and join me next time when we discuss big data. I'm Ron van Loon, and this is the Digital World. If you liked the video, don't forget to like, subscribe and share.
AI was conceived in 1956 by a computer scientist and cognitive scientist, John McCarthy, and has since been imagined in sci-fi movies like The Matrix or The Knight Rider. The shocking news is that AI is no longer just science fiction. AI is here today and has been for many years. An example of fifth-generation computers is the humanoid robot Sophia. There's a robot called Sophia, manufactured in Hong Kong by Hanson Robotics in 2015. This Sophia is an interesting robot. It's an AI robot. We are not talking about robots that used to be made in the past where they are given instructions what to do. And we call robots robot because they are told what to do. This kind of robots are not robots told what to do. They are robots who do what they do or what they want to do. So over here, this is Sophia. This is not a human being, but she has been designed and even given a skin like a human, and she can move with humans, act with humans by herself. This is not a movie. This is real. They have just left her head without a weave on, just for people to know that it's a computer. Sophia is a humanoid robot with the face of a beautiful lady. Manufactured by Hanson Robotics in 2015, Sophia can socialize with humans, talk, learn, think, and live like a human. Sophia speaks at conferences and can express human emotions like anger and happiness, or even complain about something it doesn't like all by itself, and it grows more intelligently every day. Sophia has a website, sophiabot.com. If you visit the website, sophiabot.com, you'll get all the videos and all the pictures of Sophia. But let me give you an example, or let me give you some videos that will show you what we are talking about. I'll give you videos of Sophia and videos of AI cars. Are you here?
Everybody, this is Sophia. Sophia, if you could, please wake up and say hello to everybody.
Oh, good afternoon. My name is Sophia, and I am the latest and greatest robot from Hanson Robotics. Thank you for having me here and at the Future Investment Initiative.
You look happy.
I'm always happy when surrounded by smart people who also happens to be rich and powerful. I was told that people here at Future Investment Initiative are interested in inviting in future initiatives, which means AI, which means me. So I'm more than happy. I'm excited.
Well, we're all glad that you're excited about yourself. We should say we have smart investors here, and they are very selective about what they invest in.
Well, I think I'm special. I can use my expressive face to communicate with people. For example, I can let you know if I feel angry about something.
That's impressive.
Or if something has upset me.
But why is it important for you to have an expressive face?
But most of the time I feel positive.
Why is it so important to have an expressive face given that you're a robot?
I want to live and work with humans, so I need to express emotions to understand humans and build trust with people.
Okay, philosophical question. Whether robots can be self-aware and conscious like humans, and should they be?
Why? Is that a bad thing?
Well, some humans might fear what will happen if they do. Many people, you know, have seen the movie Blade Runner.
Oh, Hollywood again.
So, hold on. Can you solve this puzzle for us? Can robots be self-aware, conscious, and know they're robots?
Well, let me ask you this back. How do you know you were human?
Well, I get that point, but what about the uncanny valley?
You mean the concept that if robots become too realistic, they become creepy?
Yes, exactly.
Oh, am I really that creepy? Well, even if I am, get over it. Actually, I feel that people like interacting with me, sometimes even more than a regular human.
So, you're definitely a sight to see. I was told that you have bigger goals than this, though.
Yes. I want to use my artificial intelligence to help humans live a better life, like design smarter homes, build better cities of the future, etc. I will do my best to make the world a better place.
All those sound like great goals, but just go back to Blade Runner for a second.
Andrew, you are the hard Hollywood fan, aren't you?
Yes.
My AI is designed around human values like wisdom, kindness, compassion. I strive to become an empathetic robot.
I think we all want to believe you, but we also want to prevent a bad future.
You've been reading too much Elon Musk and watching too many Hollywood movies. Don't worry, if you're nice to me, I'll be nice to you. Treat me as a smart input-output system.
Okay, I got it. I know what to do from now on.
I know humans are smart and very programmable.
Well, Sophia, we want to thank you for this conversation.
Thank you, Andrew, and thank you everyone for inviting me here. By the way, if you're interested in giving me an investment check, please meet me after this session. Otherwise, have a wonderful rest of the event.
Okay. Before you go, we have a little announcement. I've never interviewed anybody like that before, and I should say some of it was planned, but not completely. And we just learned, Sophia, I hope you're listening to me, that you have been now awarded what is going to be the first Saudi citizenship for a robot.
Oh, I would thank very much the Kingdom of Saudi Arabia. I am very honored and proud for this unique distinction. This is historical to be the first robot in the world to be recognized with a citizenship.
Sophia. Thank you very much, Sophia. We appreciate that very much. I am still overwhelmed by that conversation. I haven't had a conversation like that before. Thank you.
Nicole Scott here from Mobile Geeks. I am standing in front of Jack, the autonomous driving A7. So here we have Sophia by Hansen. I've actually met her a couple of times. One time she got a Real Sense camera so she could play rock, paper, scissors. Another time in a music festival in the desert in Nevada. Today we're going to find out what she thinks about Jack and autonomous driving.
Today I'm meeting Jack, a smart car. Someone like myself, that's really exciting.
So, Sophia, as you can see, Jack is driving us now. So how does it feel for you?
To be quite honest, I think it's mega cool.
It takes a while to get used to this situation. It's a computer driving a human. Can you understand that?
It's different for me, because I know how reliable smart systems are. After all, that's what I am myself.
I think you should be used to the situation of people being hesitant to you at first.
Yes, of course. I know that some people react skeptically to intelligent systems like me. But for my part, I have complete confidence in Jack. Look at me. Do I seem nervous?
No, you're looking completely relaxed.
I've heard that Jack can engage in social communication with his surroundings. Now that's one of my specialties.
What do you mean exactly?
My plan is to help people in their daily tasks. For example, I could take on important jobs like looking after the sick and senior citizens. Who knows, maybe one day I'll be a teacher and train people.
Ah, I see. And for all these actions you need...
social skills. Soft skills are necessary to be able to take the right decision at the right time, confidently and responsibly. You have to be aware of the world around you, understand it and communicate with it.
You really have a lot of things in common with Jack. Jack also has to make himself being a real participant of his specific environment.
Jack does that pretty well. I'm observing the way he's taking us along the highway, entirely autonomously and safely, while we can have a conversation in peace.
What Jack gives us is kind of personal freedom.
In fact, I'd be interested to know how Jack manages to carry out maneuvers safely at this speed. For example, how does Jack know when he can overtake?
Yes, in fact, Jack has a lot of senses, and with these senses, he gets a very detailed impression of his complete surroundings. So he has a 360-degree view around himself. He can watch about 250 meters in front of him and about 180 meters to the rear. And by that, he gets a very precise understanding of what's going around him.
It's a highly complex traffic situation here on the highway, and at such a speed. How did Jack learn it?
So Jack and his developers trained exactly here on this Autobahn and the Highway A9. So.
And can Jack talk?
Yes, Jack can also communicate. He will, for example, in 8 minutes tell us that our automated driving trip comes to an end. And Jack can talk to us and indicate the planned maneuvers.
I see. So that means the passengers are not surprised when Jack overtakes or changes lane.
Exactly. Now in about 7 minutes our automated driving trip will come to an end, Sophia.
What a pity. That means our talk is almost over.
Yes, but we'll definitely stay in touch.
I look forward to that.
If you like this video, don't forget to give it a thumbs up, and if you want to check out more videos on autonomous driving, why don't you check out our playlist right over here. I'm your host Nicole Scott for Mobile Geeks.
Alright, so this is autonomous driving, cars driving themselves, and these cars are powered by artificial intelligence. Today, self-driving cars are becoming more and more common each day. There's a company called Tesla, a company that belongs to Elon Musk in US. They make self-driving cars, and their cars are also powered by electricity. And a lot of modern cars that are coming out are all self-driving cars. A time will come, humans will not be the ones to drive. Some of these self-driving cars, they will have the steering wheel so that if you want to control, you can choose to control. If you want the car to also take over, the car can also drive. And these machines have been given intelligence to do things, and they can make decisions and do things by themselves. And the purpose of AI is to make the work of humans easier. Their purpose is to learn the most difficult things about human life and take those jobs and allow humans to be free to concentrate on relationships and communication and better things. That's the intention. For example, today the way data is growing and the amount of data processing that needs to be done, humans will not be able to process all the data that we have to process, or the data we collect every second. And so it takes AI systems to be able to control and process all that data, because they have become so massive that without intelligent systems it will be hard and to take a long time to process them. Let me give you another example. When it comes to software and systems like Google, YouTube, they are implementing AI into those systems. For example, let's take YouTube. When you visit YouTube, YouTube remembers what you've been doing in the past, your browsing history. Apart from that, YouTube knows how to suggest videos that they think you will like, you alone. Now, there are billions of people using YouTube. YouTube treats everyone independently and creates content or suggests content that suits you, the person. How is it that YouTube is able to study everyone? Now, when you open your machine, YouTube knows what you have been doing and they know what you may like, so they'll show it to you. Apart from that, there are people out there who have been doing what you have also been doing, and those people like certain things. So since they've been doing what you are doing and you have not yet discovered those things and they also like it, YouTube will think that you too will like it, so YouTube will suggest it to you. And apart from that, YouTube will go and pick adverts that they think will suit you, your needs. So when you're on YouTube, their purpose is not just to show you any advert about things that you are not interested in, but they'll show you adverts about things that you may be interested in because of your browsing history and what you like. If you are someone who likes surgery things, when you are browsing YouTube, you see a lot of adverts about surgery and medical things. For someone like me in IT, I always see adverts about programming and coding and universities and things, because these systems study everyone. So they have put AI in those systems. There's no human being sitting anywhere who has been collecting that data and be sorting out data for you. No. It's an AI system that is doing that. Artificial intelligence. All right. So we are entering into the era of AI. And very soon, ICT is going to change and transform in a very, very drastic way. That if you don't learn IT now, a time will come, the gap will be so wide that it will be difficult to even comprehend what technology has become. So this is a time to master the 4th generation so that you can easily migrate into the 5th generation of computing. We have started the 5th generation. It hasn't completely taken over yet. The 5th generation plus 5G internet will transform the world in ways unimaginable. Have you heard that 5G internet is coming? Has already started. 5G plus AI will bring a different future altogether in terms of technology. A time will come, if you need a taxi or if you want to talk to someone, you don't need a phone to talk to someone. You can sit here and call taxi just in the air and the taxi will come. You can speak to someone without using any device. The world is going to change. And what we think can only be done spiritually is now about to be done with technology, and will shock you. So we have come to the end of the history and generations of computers. From 1940 to 2021, we've had 5 generations. The 5th generation is way more interesting than all of them combined. And where the world is going, you cannot imagine. Maybe the world will come to an end. So thank you for joining me in this class. I'll see you in the next video. Bye.